Hello everyone, I apologize that I'm not in school today, but I promised you that I would post a video so that we can continue on with our plans. So here's our video for 5-2 today. I'm not giving you a quiz today because I'm not there. I don't think that would be fair to do. I will bump the 5-1 quiz to Wednesday. So Wednesday I'll cover the 5-1 and the 5-2 quiz together. So what I'm giving you a notes on today, we'll have a quiz on Wednesday. I also do not plan on having you do constructions today. That's something that I need to be there for, and I'd like you to at least watch the video. On Schoology, I have a video posted of me doing the constructions. So I want you to just look at it to be exposed to it, and then we'll do it hands-on in class on Wednesday. So 5-2, perpendicular bisector notes. This is going to be a little bit awkward. I'm going to do the best I can to make this as clear as I can for you guys. So perpendicular bisectors, we know that a perpendicular line meets another line at a 90-degree angle. We also know that a bisector divides a segment into two equal segments. So perpendicular bisector should make sense that this segment AB is bisected by this segment, creating two equal parts. So AP, this length right here, is the same distance as this length here. So CP is doing the bisecting, it's cutting AB exactly in half, and it's meeting it at a 90-degree angle. So CP is a perpendicular bisector of AB. So again, it meets it at a 90-degree angle, it splits it into two equal segments. Perpendicular bisector theorem. If a point is on the perpendicular bisector, then it's equidistant to the endpoints of the segment. So think about what this means. This is a perpendicular bisector. We can see that because it meets it at 90 degrees, it splits it into two equal segments. So because I know that C is on this perpendicular bisector, then that means that from C to this endpoint and C to this endpoint is the same distance. So again, because C is on the perpendicular bisector, it's equidistant to each of the endpoints. CA and CB are congruent. The converse of the perpendicular bisector theorem, you can see my pictures up here versus my pictures down here are opposite. We know what a converse is. You switch the hypothesis and the conclusion. This should make sense to you. So if I have a point, C, that is equidistant to the endpoints, you can see that in my picture, C is equidistant to these endpoints on this line, then I know that C is on that perpendicular bisector. So if it's equidistant to the endpoints, CA and CB are congruent, then I know C is on that perpendicular bisector. So let's apply this to some examples. This is example 1. It tells us here that EH is the perpendicular bisector of DF. So if you look at my picture here, here's DF, and it tells us that EH is a perpendicular bisector. So that means it meets at 90 degrees, and it means that these two segments are the same. Now we're asked to find some segments. So the first one, we're asked to find EF. So we're asked to find this distance right here. Well, remember our theorems just a minute ago. E is on the perpendicular bisector. Maybe you can't see that. E is on the perpendicular bisector, so I know that EF and ED are congruent. So I'm going to use these two expressions and set them equal to each other. So that's what I did over here. I set 7x plus 9 equals 9x minus 1 and solved for x. I found that x is 5. And again, I need to find what EF is. So I plug 5 into this expression. So 7 times 5 plus 9, EF is 44. The next thing we're asked to find is FG. So looking back over here, FG and GD are congruent because it's marked that way. So because it's congruent, we're going to set these two equal to each other. So that's what I did over here. 7y plus 8 equals 10y minus 4. When that's solved, you get y is 4. So again, we're finding FG, so we plugged 4 in for X, and FG is 36. One last one, we're asked to find DF, which is from here to here. Notice that we're given this segment to be 3x plus 4y. Well, we know what x and y are. So we can plug in 3x plus 4y. Remember, x was 5 and 4 was y. And we know that this is an entire segment is 2 equal segments. So I have this segment, which is 3x plus y, but this segment is also 3x plus y. So what I did here was 3x plus 4y and multiplied it by 2, which would give me that entire length. Hopefully that makes sense to you. On our next page of notes, this is a construction, and I had planned on doing this construction with you, and we will, just not today. I want you to see kind of what it looks like. So it's not just taking a ruler and eyeballing and drawing perpendicular bisectors. What we end up doing is using a compass and drawing arcs so that it's very accurate. So what I did on my notes here, these arcs are what I use my compass for to make my perpendicular bisectors accurate. And I do have a video that I would like you guys to watch. I believe it's a pretty short video. Again, I want you to just be familiar with it so that when we do it in class, it'll be a little easier for you. So on my constructions, I don't know if you can tell that these are blue lines. These solid lines are my perpendicular bisectors. So this is a perpendicular bisector, this is a perpendicular bisector, this is a perpendicular bisector. The perpendicular bisectors meet at a point of concurrency. That means that it's a meeting point of a bunch of lines, rays, or segments. In this case, it's a meeting point of all the perpendicular bisectors. In this case, because it's a meeting point of all the perpendicular bisectors, that point is called the circumcenter. So again, the circumcenter is the meeting point of all perpendicular bisectors. Taking that a step further, you can see that I have dotted lines drawn here. So I did my construction to identify the circumcenter. The next part of information that you need to know is that the circumcenter is equidistant to each vertex. So blue is perpendicular bisectors. These green dotted lines are all the same length. So from here to here is the same length as here to here, is the same length as here to here. So circumcenter is the meeting point of perpendicular bisectors and equidistant to each vertex. That's the big takeaway from today. Okay, let's take a look at this example. So look at what's given to you. It says the perpendicular bisectors of ABC meet at point G and are shown as dashed lines. So this is a perpendicular bisector. So I know perpendicular and I know these two segments are the same. DG is a perpendicular bisector. Meets at 90 degrees, these two segments are the same. This dotted line is a perpendicular bisector. I should make these two lines. And these two segments are the same. Now we're asked to find a lot of different things in this picture. So let me just go through these with you. The first one asked you to find AG. So from here to here. Remember, these dotted lines are our perpendicular bisectors. So I know that G is the circumcenter. From the circumcenter to any vertex is all the same. So this line, and this line are all the same. So you can see that they already gave you GC is 25. So I know that this one's 25 and this one's 25. The next one asks us to find BD. BD is this segment right here. So if AD is 20, BD also has to be 20 because we know that dotted line, this dotted line right here, is a perpendicular bisector, which means AD and DB are the same length. The next one, we're asked to find CF. So CF is going to be the same as AF because this little line is a perpendicular bisector. So if this one's 24, this also has to be 24. AC, let's find AC. AC is from here to here. We're given AF is 24. We know FC also has to be 24, so that entire length has to be 48. As always, guys, I caution you not to just assume and slap answers in there. Make sure you're understanding what you're doing and why, because there's going to be very similar problems in other triangle centers and you'll get confused very quickly. So again, circumcenter is the meeting point of perpendicular bisectors, equal distance to each vertex. That's what you need to know for today. Find BG. So BG is from a vertex to the circumcenter. Vertex to circumcenter, all of these green are the same. And if you use colors when you do these kinds of problems, I think it is very helpful, because then you can see the difference between perpendicular bisectors and the distance from a circumcenter to a vertex. And the last one is CE. So remember, E is my midpoint because this is a perpendicular bisector. So if BE is 15, then EC also has to be 15. I do want to point out, I'm not sure if there's a problem in your notes from your homework like this. I want to point out that there's right triangles here. Look at this triangle here. Let me pull this out for a second. So this is ADG. I pulled this triangle out. We know this is 90. We know this is 20. We also know that this green segment is 25. You could use the Pythagorean theorem and figure out that one unknown side. So everything that's going on in this picture, you can figure out all of those lengths only by given a small amount of information. If you need help with these kinds of problems, of course, I can help you with it. And I believe that's the end of our notes. So here's the homework. I do want you to do the homework. Here, let me do this. Do the homework, check the homework, watch that short video of me doing the circumcenter construction. I will always help you guys with anything before I grade anything. If you have questions, you can always email me. I'll do my best to check email today. And I will see you guys in school on Wednesday.